Hello and welcome to lesson 2-3. Today we're going to look at simplifying variable expressions. Specifically, we're going to look at identifying parts of a variable expression and then we're going to simplify them. So before we begin, we need to understand what the parts of a variable expression are. So if we look at the example, 7a plus 4a plus 3b minus 6, when we look at a term is a number or the product of a number and a variable. So looking at our example up here, okay, I would say, or if we look at this, we have four terms. I have 7a as a term, 4a is a term, 3b is a term, and a negative 6 is a term. When we look at a constant means that it's something that doesn't change or that the term does not have a variable. So the only term from up above that does not have a variable is the negative 6. Then like terms are things that have identical variables. So from our example above, we have 7a, 4a, 3b, and negative 6. The 7a and 4a, they both have the same variable. That way, 7a and 4a are what we would call like terms because they both have the same variable. And then when we look at a coefficient is a number that multiplies a variable. So that means it's a number in front of a variable in this case. So our coefficients would be 7, 4, and 3. So for example 1, it says name the coefficients, like terms, and constants from each expression. So if I look at 3m minus 2n plus n minus 4, my coefficients are going to be 3. That's the number in front of the variables. So I have 3, negative 2, and technically I have a number 1 in front of that n. So it'd be 3, negative 2, and 1. My like terms are going to be the negative 2n and n. And the constant is going to be the number without a variable, which in this case is going to be negative 4. Likewise, for the second part, our coefficients are going to be the number in front of the variable, or 2s, and 4 in front of the s. Our like terms are going to be 2s and 4s. And then our constant is going to be the number without a variable, which in this case is 6. So go ahead and try this one on your own. So now that you've had a chance, our coefficients for the first one would just be the negative 4. For like terms on this one, we have none, okay, because we've only got the one term. And then our constants, in this case, I have no terms that do not have a variable, so this here would also be none. Likewise, for the second example, our coefficients are going to be 9, 2, negative 2, and 1. Our like terms are going to be 9m and a negative 2m, as well as 2r and r. And then our constants in this case would be none because every term has a variable. So sometimes you're going to find out that it's going to help us if we can simplify a variable expression. So we say that we're simplifying a variable expression. It says that we're going to replace it with an equivalent expression that has as few terms as possible. And we also know this as combining like terms. Okay, so it's just going to make things look a little bit neater. So for example 3, we're told that we have 5y plus y. So because these are like terms, or they both have a y term, I can really take my 5y and add it to 1y, and I get 6y. For the second part, I have 3b minus b. These are like terms, so I can go ahead and add or subtract. And 3b minus b is going to give me 2b. For the next one, I have negative 4m minus 9m. Well, negative 4, if I change this to plus a negative 4m plus a negative 9m gives me a negative 13m. And then for my last one, we have p plus 6p minus 4p. Again, all of these have a p, so I can combine them. So 1p plus 6p is 7p minus 4p gives me 3p. For example 4, we're told to simplify. So here, I'm going to have to distribute first. So this is going to give me 4g plus 9 plus 3g. Then I'm going to have to go ahead and combine my like terms. So really I have 4 plus 3g, which gives me 7g plus 9. And this here would be my final answer. If I go to part B, I have 6y plus 4m minus 7y plus m. So 6y minus 7y, because I'm collecting my like terms, will give me a negative y. Then I have 4m plus m, so I have plus 5m. This is my final answer here. And then for my last part, we have 4x plus 3 minus, so I have negative 2 times 5, which gives me minus 10. Negative 2 times x gives me a negative or minus 2x. So now I'm going to simplify. So 4x minus 2x will give me 2x. And then I have 3 minus 10, which gives me a negative 7. Or if you wanted to, you could write that as 2x plus a negative 7. Either one of these would work. For example 5, it says a family ordered P pizzas at $12 each and an order of breadsticks for $5. There's a $3 delivery charge. Write and simplify a variable expression to model this situation. So we have P pizzas at $12 each. So to find out the cost of this, we know that we're going to have to take our cost of the pizza and multiply it by the number of pizzas that were purchased. Then they bought an order of breadsticks that was $5, and we had to pay a $3 delivery charge. So here's our expression, and we're just going to go ahead and simplify it. So this ends up being 12p plus 8, because I can combine my like terms here. And this is the expression to find the total cost. And our final example for today says, John is buying candy for Halloween. He buys 1 bag of Snickers that has 40 pieces in it. He plans to buy X bags of Kit Kats with 30 pieces in each bag. He'll also buy X bag of Twizzlers with 50 pieces. John gets hungry and ate 4 Snickers while waiting for the trick-or-treaters to arrive. Write and simplify a variable expression for the number of pieces of candy John will have to pass out. So, to start out with, it says he buys 1 bag of Snickers that has 40 pieces. So we know we have 40. Then he buys X bags of Kit Kats with 30 pieces. So that's going to become plus 30x. Then he buys X bag of Twizzlers with 50 pieces. Then he eats 4 Snickers. So then we're going to subtract 4. And this is my variable expression. Now I need to simplify it. So to simplify it, I have 30 plus 50, which will give me 80x. And then I have 40 minus 4, which will be plus 36. So 80x plus 36 will be my final answer. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I will see you in class.